Hi everyone. So today I'm starting a new lecture on the chi-square distribution. As you know, which is a type of a parametric distribution. And in this lecture, I will be discussing some important theorems and examples. So kindly watch the whole lecture. And this lecture will be your most important lecture from the concept point of view, and I will be discussing some examples as well. Right, example will be based on the chi-square only. So here is the result. Let's start from the result. The result is something like that if x and y be independent chi-square variates with m and n degrees of freedom, then then the f, which is written like this, x by m divided by y by n. So see here, this x is my chi-square. This is chi-square divided by degrees of freedom. This is also chi-square with degrees of freedom, that's n. So this will follow f distribution with m comma n degrees of freedom. You have to remember this only. ये हम पढ़ेंगे f distribution में कि f distribution और chi-square में क्या relation है. So chi-square divided by degrees of freedom whole divided by chi-square with n degrees of freedom, where chi-square divided by m represents x and chi-square divided by n represents y. Then you can say x divided by degrees of freedom of x, which is a chi-square variate, divided by y by n will follow f m comma n. And you need to remember that PDF of f is gamma m plus n divided by 2 gamma m by 2 gamma n by 2. Then m divided by n, m by n multiply f or multiply x, you can say multiply x, m by 2 minus 1 divided by 1 plus m by nx, m plus n divided by 2, where x is greater than 0. So this is the relation between chi-square and f distribution, but you have not studied f distribution, but for now remember this only, right? Then the second result is the same based on the chi-square. That's result number 2. That is, let x and y be independent and let x follows normal 0 comma 1 and y follows chi-square with n degrees of freedom. Then t is equal to x divided by under root of y by n, that's degrees of freedom of this. Y, what's y? Y is chi-square divided by degrees of freedom of y, and this will follow t with degrees of freedom n. And same, you have not studied the t distribution, but for now remember these two results only. Then PDF of t is gamma n plus 1 divided by 2 gamma n by 2 gamma n by 2 gamma n by 2, that is under root of n pi 1 plus t square upon n raised power minus n plus 1 divided by 2, where t is between minus infinity to infinity. This is the PDF of t distribution. And in this t distribution, if n is equal to 1, so this distribution reduces to Cauchy distribution. Cauchy distribution. So you need to you don't need to remember this for now. जब हम t distribution पढ़ेंगे तब ये सारी चीजें फिर से आएगी. But here you need to remember chi-square and t. What's the relation between chi-square and t? How they are related. So see, when we have in numerator, that's x, which is a standard normal variate, divided by chi-square with degrees of freedom, chi-square divided by degrees of freedom, this will follow Tn, right? So this is the PDF of T distribution. So now see, most important concept here is, concept is x1, x2, x3 up to xn. This will follow normal mu comma sigma square. Then x bar and xi minus x bar comma x2 minus x bar comma x3 minus x bar comma up to xn minus x bar are independent. So let's talk on the independence. See, whenever you are asked to prove the independence, we have the three methods. In general. First one is that the joint distribution will be equal to their marginals. If this happens, then we can say the two distributions are independent, right? Let's suppose we have e raised power minus x minus y. So can I write this as e raised power minus x, e raised power minus y? So this is my f of x. This is my f of x comma y, and this is f of x, and this is f of y. So we can say these are the independent. X and y are independent. दूसरा method जो है, that is when covariance between x comma y is equal to 0. X and y are called independent, then a covariance will be 0. X and y are independent, then covariance x comma y is equal to 0. Number 3, when mgf of x plus y is equal to mxt multiply myt. In general, we use this mgf to prove the independence in sampling distribution or joint distribution. Mostly we prefer mgf. So see, the proof of the above result, the result is that we have x bar and x1 minus x bar, x2 minus x bar are independent. So how to prove this result? Let's see. we have m t1 t2 up to tn. This is the mgf of n random variable. That is expectation of e t1 x bar plus, or simply t x bar plus t1 x1 minus x bar t2 x2 minus x bar plus tn xn minus x bar. Clear? So this is equal to expectation of e summation ti xi minus summation ti minus t x bar, and this will be equal to expectation of e summation xi ti minus t1 plus t2, this is t here, plus t2 up to tn divided by n minus t. So this is also equal to expectation of product e raised power xi nti minus nt bar plus t divided by n, where t bar is equal to summation ti upon n, and this will be equal to product of expectation of e xi t plus n ti minus t bar divided by n. So this will be equal to product of e raised power mu t plus n ti minus t bar divided by n plus sigma square upon 2 1 upon n square t plus n ti minus t bar whole square, and this will be simply equal to e raised power mu upon n nt plus n summation ti minus t bar plus sigma square upon 2n square summation ti plus n ti minus t bar square, and this will be equal to e mu t e sigma square upon 2n nt square plus n square summation ti minus t bar square, and this will be equal to e mu t plus sigma square upon 2n square t square multiply nt plus n square summation ti minus t bar square, and this will be equal to e mu t plus sigma square 2n square t square into e sigma square by 2 summation ti minus t bar square, and this will be equal to m x bar t multiply m xi minus x bar comma x2 minus x bar up to xn minus x bar t1 t2 up to tn. So from this you can see that MGF of T1, T2 up to Tn will be written like this. This is MGF of T1, T2 up to Tn will be MGF of X bar. This is M xt multiply M summation xi minus x bar. Right? So x bar and xi minus x bar summation xi minus x bar are independent. What I told you that whenever mgf of x plus yt is equal to mxt multiply myt, then we can say x and y are independent. Clear? Now, corollary of this theorem is x bar and s square are independent. That is, what's s square is equal to 1 upon n minus 1 summation xi minus x bar square. When xi minus x bar is when x bar and xi minus x bar is independent, then x bar and s square are also independent. And corollary number 2 is n minus 1 s square upon sigma square will follow chi square n minus 1 degrees of freedom. Clear? So if I take the expectation of this will be expectation of s square divided by sigma square into n minus 1 will be equal to n minus 1. This n minus 1, this n minus 1 goes. Expectation of s square will be equal to sigma square. So we can say this is unbiased estimator plus consistent estimator. That this expectation of s square is sigma square. We will see this in inference chapter, but you have to remember this for now. Now, see. Mode of chi-square distribution. So what's mode of chi-square distribution? That's simply n minus 2, where n minus 2 is less or equal to 0. Here n is less or equal to 2. See, mode, what's mode? Mode is a maximum value simply. How to obtain that maximum value? We know if we have the function f of x, what we can do with this function, we simply differentiate with respect to x and put that equal to 0. Then we obtain f double dash x, that's the double differentiation of that f of x, that will be less than 0 or greater than 0. If this is less than 0, then we get the maxima. That's maximum value, that's mode. And if this is greater than 0, we will get the minima, simply. So here we have f of xx, that's the distribution of chi-square, that's 2n by 2 gamma n by 2 e raised power minus x by 2 x n by 2 minus 1, and this is between this. So what we will do with this, we will find f dash x and put that equal to 0, and then we will see f double dash x, this will be less than 0, then the mode will be maximum, that we will get the maximum value simply. So see how we can obtain the f dash x. That is simply, we have the PDF, that is this. So differentiate this with respect to x. So this is the constant. So this is the constant. 2n by 2 gamma n by 2 is my constant. Now differentiation of this will be my u multiply v. So differentiation of uv with respect to x is d du upon dx plus u dv upon dx. So treat uv as the constant in differentiation of u plus treat u as the constant in differentiation of v. So same will be here. So this will be e raised power minus x by 2 minus 1 by 2. So internal differentiation of this will get multiply here. Then x n by 2 minus 1 plus this will be constant and differentiation of this will be power down x n by 2 minus 1 minus 1. As you know, x raised power n dx raised power n by dx. This is power down x n minus 1. Clear? So this will be equal to, this is my constant. What will come out from this term as a constant? Not as a constant but as a common term. So this is the variable. So here is the involvement of variable. So what will be the common term here? The common term will be this, clear, and this. So e raised power minus x by 2, x n by 2 minus 1 will be my common. So here I will be left with minus 1 by 2 plus n by 2 minus 1, and here x raised power minus 1. So n by 2 minus 1 will be common. We will be left with this only. So see, f dash x will be 0 when this will be 0. So this will be 0, this will be 0. When this will be 0, this will automatically will be 0. This should be 0, right? This should be 0. So minus 1 by 2 plus n by 2 minus 1 x minus 1, that's inverse, is equal to 0. So n minus 2 upon 2 x minus 1 is equal to 1 by 2. So n minus 2 x inverse is equal to 1. So x inverse will be 1 upon n minus 2. So x will be n minus 2. So this is my value of x. Add this value of x, add this value, f of x will be maximum. But for this we need the double derivative, that's f double dash x. Whenever you find this f double dash x, this will be always equal to 0. When, if x is equal to n minus 2 or n minus 2 will be less than 0, less or equal to 0. So find this, and this will always be less than 0. Then our maximum value will be at n minus 2. Then put that x is equal to n minus 2 in f of x. The value after putting n minus 2 in the main equation, you will get the maximum value, that is at n minus 2. So mode is n minus 2 at the value of x, that is my mode. So x is equal to n minus 2 is my mode, right? So what will be the effect of this n minus 2, x is equal to n minus 2 on my graph of the chi-square distribution? Let's write this as the in the raw format. So in next lecture we will see the graph of the chi-square distribution, but I'm telling you the exact what will be the effect of n minus 2. See, the graph will be for different degrees of freedom. For different degrees of freedom, this is my x, this is my f of x. So see, this is 0.5, and this is at n is equal to 1 degrees of freedom, and this is for n is equal to 2 degrees of freedom. See, n minus 2 should be less or equal to 0. Whenever I put n is equal to 3, the graph changes. The graph will change like this. For n is equal to 3, for n is equal to 4. See, for higher degrees of freedom, the graph changes from n is equal to 3, 4, 5. Then we will get only the maximum value at n is equal to 2, that is 0. Where f of x, f dash x will be 0, that will be our maximum value. So at x is equal to 2, so this is at n is equal to 2 minus 2 is equal to 0. So at x n minus 2, we will get the maximum value. That's my mode. That is my mode. That's my simply mode. Right. So graph starts from this far. N degrees n is equal to 1. Then n is equal to 2. The value will be f of x value will be 0.5. And for n degrees of freedom, n is equal to 2, we will get the curve like this, and n is equal to 3, we will see the curve like this, right? Now let's do a simple question. The question is, let x be a continuous random variable with PDF. F of x is equal to 1 by 3 x7 e raised power minus x squared, where x is greater than 0. Then find the distribution of w is equal to 2x squared. So say, for this question, you have to know about the transformation, that is transformation, which transformation that I am going to apply here, that simply f of new variable is equal to f of old variable multiply Jacobian. So let's do a transformation here. Transformation is let w is equal to 2x square. So w by 2 is equal to x square. So under root of w by 2 is equal to x. Now differentiate this, we will get 1 upon 2 root w upon root 2. That's dw is equal to dx, right? So I will get root 2 multiply root 2, 2 root 2 root w. dw is equal to dx. So this and this goes. So I will be left with 1 upon root 2 w is equal to, this is dw is equal to dx. So now see, what's my f of new variable? That will be f of w is equal to f of old variable, that's 1 by 3 x7 e raised power minus x square into Jacobian. Jacobian is 1 by root 2 w. Clear? So now in place of this x, replace this x by w by 2. 1 by 3 root w by 2 raised power 7 e raised power minus root w by 2 square divided by 1 upon root 2 w. So say this is equal to 1 upon 3 root w, or simply w 7 by 2 7 by 2 e raised power minus w by 2 divided by 2 1 by 2 w 1 by 2. This will be equal to 1 by 3 w 7 by 2 minus 1 by 2 7 by 2 minus 1 by 2. Seven by 2, 1 by 2. 7 minus 1, that is equal to this, huh? So this will be equal to 2 7 by 2 plus 1 by 2 e raised power minus w by 2. So this will be equal to 1 by 3 2 4 w 6 e raised power minus w by 2. Clear? So here, what's my PDF of chi-square? What's my PDF of chi-square? That is simply 1 upon gamma n by 2 2 n by 2 x n by 2 minus 1 e raised power minus x by 2. So here 6 is equal to n by 2 minus 1. So this is 6 5 5. This is not 5. 6 plus 1 7 is equal to n by 2. N is equal to 14, but this is incorrect. The answer is n is equal to 8. Why I am getting this wrong, I don't know why. Did I think I did a mistake, but I don't know where. This is W7 by 2. If we subtract this minus 1 by 2, this is 6 by 2, that's 3, that's correct. Here is for W by 2, 1 by 3, 2 raised power 4. Gamma n by 2 should be equal to, this should be equal to 3. How this should be equal to 3? Not this should be equal to exactly 3. But the procedure is correct. Do yourself and let me know in the comment section कि मैंने कहाँ पे गलती की है. ठीक है? So the answer is, I guess that 2x will follow chi-square 8.